Are we good? I think we're good. Okay. Okay, awesome. I started getting weird streaming errors and whatnot in my Streamlabs. I wanted to make sure you could all see what was going on. Just got out of a school Zoom meeting, so I don't know if that was sucking up my bandwidth. All right, so we got a lot to get through today. We have to wrap up this project management stuff. We have to do a little bit of a demo. And I have to remind you right now that you have homework due tonight, so don't forget about that. So we have that. And after your homework is in, I will probably either Saturday or Sunday, I'll put up the next assignment. It's going to be project management type stuff, which, hey, we're talking about. Basically, I'm just asking you to figure out what tasks you have done already, what you have remaining to do. And make this a wee bit bigger here. Oops, wrong guy. There we go. Basically, plot out your tasks and how long you're expecting everything to take. And this is going to do two things. One, you're going to be talking about it during your midterm presentation, which I'm just kind of finalizing some of the points I want you all to talk about and making it nice and pretty so that you have a nice rubric to hit. So basically, I'm going to be caring about your vision of planning out your whole project and where you're at and what you have left to do and how you're going to make that happen. So just be aware if you are starting to think about remaining tasks for, the next month and a half, you're going to be putting it down to paper. And hopefully that will be helpful for you. So without further ado, I left you here talking about cost estimation techniques, right? And I talked about a work breakdown structure, and we ended right about here, where we started breaking down all the tasks of what you need to build an aircraft system, right? So we would try to figure out approximately how much time each one of these tasks would take. Now, what we can also do is we can look at other projects. So maybe our company has a set of similar projects that we've done in the past. And then we can take any cost estimations that we've applied to those and try to bring it in for our current project. So if we did an embedded system before and we have to do another one that's very similar, odds are the cost estimations are going to be roughly the same. So in this regard, we have cost estimation by analogy. Still kind of iffy if it's correct, right? Because we're going to have our own issues and whatnot for the current project. However, we might have a good idea for what's going on there. We have another, it relates to a law. So we talked about Parkinson's Law a while back. We talked about like Murphy's Law and all the things that can impact a project. Parkinson's Law is an interesting one in that if you define a particular time span for work, you will fill that time with work. It's just the nature of things, basically. So if I have a project and I say it's going to take me, I have a year to work on this project, I will be busy that entire year. Even if it takes me 2 months for the core development, I can still take 10 months to backfill it with analysis and backfill it with refinements and quality control and things of that nature. So for instance, we can spec out projects by time. So we have 12 months, and that's how long you have for a project. We have 5 people available. That means that we have 60 person months worth of effort we can expend, and whatever is done after 12 months is the project. So basically what you can do is you can set the timing in stone and figure everything else out from that point, right? So we can have time-based methods. We can also have cost-based methods. So we are figuring out cost for a project. Again, effort, timing, project, people, whatever we're estimating cost as. It can be derived from the money the customer has. If you are going to give me $1 million to work on this project, I will use that $1 million, and anything over that, we're not going to be able to deliver, right? So whatever effort we're going to expend depends on how much you're willing to pay. You go on, put $20 down on Fiverr for somebody to do a small bit of work for you, you're going to get $20 worth of effort, right? So that's the pricing model for cost estimation. With all these techniques, I kind of hope, I'm kind of zipping right into them because I want to get through what we have to talk about today. But all of these techniques are basically setting one thing in stone, right? Whether it's time, whether it's money, whether it's looking at other projects, and we are kind of backfilling our efforts from that point, right? And the last one we're going to talk about before we get into the kind of the meat of today is the schedule-driven one. This is where it's similar to the Parkinson's Law estimation technique where we're going based on time, except here we are going based on resources. But resources can be tied to a schedule, so it's still kind of timing based. And what does this mean? Well, here we're going to estimate the schedule. It's not necessarily going to be set in stone. It's going to be related to resource availability and things of that nature. So if you're trying to understand the difference between Parkinson's law, between schedule-based, Parkinson's is more rigid in terms of timing, whereas this one is a little bit more flexible. But these are kind of, basically hand-wavy types of estimations at this point, right? We are just saying we will set this thing in stone and estimate cost from there. We can also get into the algorithmic side of things, and this is where you apply a model to your problem. And I should mention, if we hit 135, somebody please stop me because that's where I want to do a hard stop and do some demo work. But the model side of things is basically where we're going to use an empirically derived model. We're going to give it some inputs. We're going to give it, particular parameters for a problem, and we are going to get effort and cost as an output. Now, an algorithmic model is effectively like a mathematical set of equations where we plug in values, we get an answer out. Your output is only as good as your model and only as good as what you put into it. And we're going to see that here momentarily. So first things first, I used a term called empirical. Does anybody know what empirical means? So it is a empirical model. So what we're going to be talking about here is Kokomo, which is one of the more common algorithmic models that are out there. Constructive cost model, but it's an empirical model. An empirical has a very specific meaning. Make sure I get my slide count here. Curious. I don't have any slide-dos for you today, so just chat interaction if you know. If you don't know, that's fine as well. The odds that you know what empirical mean are pretty much tied to the fact if you've ever done any experimental work. So I'll give you a hint. Empirical is basically experiment driven. So the sentence here, derived by collecting data from a large number of completed software projects. So what empirical means is that we are basically figuring out what this model is, what the magic numbers are that plug into the model, simply by looking at past experience. So if you have a software project and you have a bunch of, they're called magic numbers if you're not aware of that, but like you have x equals 5 or velocity equals 22.9. I'm just picking random numbers. But these are all magic numbers where they have meaning to you, the developer. If I come in and read your code and I see x equals 500, I'm going to ask you what that means and where you got that value from. It's a magic number. You can say, well, it was empirically derived because I have seen in the past that this works. So basically, it's just experimental data supports your notion, right? So the success of this model basically is derived from past projects, past successes, and basically analyzing a large number of things out there and coming to a common model that ideally you could use for a project. Again, this is the black box style where we give it some input and we get an effort and a schedule out of it. So I will say there are two variants of Kokomo. So there is 1 and 2. Kokomo 1 was made in the early 80s. This one is really apt for waterfall. So again, kind of that older software design process. There is a lot more rigidity in your system. We know the requirements, we know the resources, the design, so on and so forth very early on, right? And then it gets set in stone. Is that what life is like today? Well, some people still use that. Kokomo 1 is still perfectly fine. There are a lot of groups that are using Agile. There are a lot of groups using prototyping or Spiral, and it doesn't necessarily mesh nicely with those because there's a lot more flexibility. So the model was updated. If you are good with Kokomo 1, you can probably do Kokomo 2. Again, it's an empirical mathematical model that we're going to plug numbers in, and that's what we're going to take it as. You're not the developers for extending this model. You are simply practitioners using it. So we have to know what numbers to put where. It's usually good to know why it works, but you don't have to worry about like, well, how do I extend this for this problem? We just have to be able to use it correctly. We're going to talk about Kokomo 1 today. Kokomo 2 I will leave as an exercise to the student if you want to read it. And being a student not that long ago, I still remember my professor saying it's an exercise to the student, meaning that they don't want to talk about it today. So what do we care about in a Kokomo model? This is going to estimate, again, effort and schedule based on the size of the project. There are some subjective points here. There are some hard key metrics. We can go in scale of complexity depending on how good we want the model to be. But at its core, it's going to look at the actual code base. And this could be an estimated code base, right? So first things first, we care about how many lines of code have to be written. And this is not comments, right? Comments are basically superfluous. They don't have any impact. So yes, it takes effort to write them, but it doesn't, we're not going to validate comments. We care about how many thousands of lines of code you have to write. Functional, executing code. By itself, is that a good measure of software effort? No. I mean, think of any application you would write today, something that is like node-based or Electron-based or even Python, Java even, I suppose, where you're pulling in lots of frameworks, lots of modules. It's very easy to get bloated code bases that reach in the thousands of lines of code, right? So by itself, it's not a good measure. I can write a bunch of crap code that just upset line counts. Does the same thing as a very pretty one-liner. But just kind of a takeaway that you don't always estimate based on lines of code. This is kind of a, again, purely looking at how many lines of code you have to write. This is a very antiquated way to measure progress or measure effort. But that's only one point. We also care about the function points, the application points. So how many inputs and outputs do we have to handle? Right? This could be external APIs, it could be people interacting with your system, it could be reaching out to files or databases or basically any kind of interaction our system can have. We will categorize these and we will include them as part of the model. We also might care about how many interfaces we have to write, user interfaces, how many GUIs, how many components have to be brought in. So looking at these last bullets here, and before Google hides it on me, you know, how many user interface screens, for example, to take that first point, let's say you're writing a phone application, I need a login screen, I need a main window, I need an options window, I need a profile window, right? These are all separate screens that have to be developed. Or if it's your game, if you're working on the game, right? You need a main menu, you need level 1, level 2, level 3, level N, if you're coding them all by hand. Just depends on how much effort you have to expend there. Reports, even. A lot of your common applications will produce reports. You have to yank out all of the data that needs to go into that report. You have to format it. You have to put it into PDF valid format, right? So that it can actually be read by Adobe or whatever your reader of preference is. So again, this is all efforts that we have to expend, and it's all categorized in this algorithmic model. So here's a black box view of the system. If you are not familiar with the black box model of things, basically we have things going in, we have things going out. And the black box is that things are happening inside, right? So we're going to take this data, we're going to do stuff to it. That's our algorithmic model. And then we're going to get some nice clean outputs. How much effort has to be expended? What's the schedule that we can expect? So here's your kilo lines of code. And then we have our mode and our cost driver ratings. I haven't talked about these yet, but basically it's how complicated of a model do you want and how many things are going to impact this model. All right, so this is going to be the subjective nature of things, like how good do your requirements have to be, or how good are your people and your staff, things of that nature. Again, some of them are qualitative, some are quantitative. It just kind of depends on them, and we'll be getting into this as well. Please feel free to stop me if you have any questions, but you're basically kind of getting an info dump on Kokomo today. So there are 3 levels for Kokomo, and then there are going to be 3 development modes, which I'll talk about in the next slide. And this is how much data you're going to put into the model at which point in your project. So very early on, you may have a notion of how much effort this project's going to take lines of code wise. So if I'm writing a phone application, I know I'm going to need, 100 lines of code to do my basic interface or to do my basic main menu or my home screen, right? Because I've written them before. I know about how much effort that would be. So the basic model is going to be strictly that simplistic view. How many lines of code do we have? This is something you do pretty early on in the project before you get through requirements and design and staffing and all of that fun stuff, right? We're just trying to get kind of an estimate of what it would take. We're going to use that estimate to inform the rest of our development process. And then let's say we get further along in our project, we've done our requirements. We can take that program size, refine it if we need to, and then add in some of our other assessments that we may have as project managers, right? So subjective assessments of the product, what computers we have, what personnel we have, maybe specific attributes that we have. And I'm going to get to this in a, actually, let me pull it up right now because otherwise this isn't going to make any sense what I'm talking about. So I've got an associated website here, and the link is in one of the upcoming slides, but this is a Geeks for Geeks blog post basically on Kokomo. And it goes through everything that I'm talking about, some of the magic numbers that I'll be describing. But these cost indicators, let me scroll down here. Again, magic numbers in a table, but how important is the reliability of your software? How important is runtime performance or memory? Or how good are your analysts or your software engineers, right? So these are all kind of the subjective things that you, as a project manager, would try to say, this is maybe very low. So I don't necessarily care about the reliability of my requirements or my software. If it's a embedded safety critical system, I better damn well sure make that these are good requirements, make sure they're good requirements, right? So we're going to have a lot higher of an impact. So I'm going to refer back to this post here and there to kind of show you what some of these values are. But when I say like these cost drivers, subjective assessments, you are subjectively, meaning you're kind of going with your instinct of how good your personnel are or how important the requirements are. And again, keep in mind, this is an estimation of effort. It's not, necessarily what it actually is, because you might have very good people, but you are not aware of their capabilities yet. All right, so we have intermediate, and then we also have advanced, where we have more information. We've done requirements, now we've done design as well. We can augment those cost drivers with more data. All right, so we have 3 different levels. Now we have 3 different development modes. We can apply Kokomo to an organic system where you basically have a somewhat small, simple project. Your teams have probably come together organically. Requirements are a little bit less rigid, more fluid, very flexible. So you have kind of think of it like your term project teams, right? You came together very organically. Your projects are being kind of run by the seat of your pants as you add new features and as I have you put down requirements and use cases and all that, right? So very organic. what does this mean in terms of Kokomo? Well, there is a field called organic. Okay. And out of that field, you pick the associated parameters for the equation. That's all it really means here. We also have semi-detached, where we have, kind of middling complexity. You might not just have a small agile team. You might have a rigorously defined project structure with junior and senior engineers. You might have quality analysts. So basically, you have kind of a more business environment like type of situation. More structured is maybe a better word. You can also look at it from the embedded perspective, where your project is very tight in terms of constraints. So it might be safety critical, it might be very rigid, where any deviations are going to have significant problems, right? So think of it like you're developing an not an airframe, but you're developing an airplane or a vehicle or a system that is embedded that has to have very hard constraints. Again, what does this mean for the model? It's just the type of project that you're applying here. So here's the link that I was talking about, and this is the general formula that we have. So out of this model, first we're getting effort, and then we're getting a schedule. So it's going to be the development time, basically. But here, this is going to be basically person months. So we have a constant C, we have a constant K, we have a constant M. So we have a multiplier here. We have how many lines of code we have. We have an exponential here. And then this M is going to be your cost drivers. So again, let me pop back to this table here, or this page, because it's pretty feature rich. Let's say you are an organic project. All right. And these equations here are slightly different from the ones I'm showing you. They're kind of broken down a little bit more. But are you organic, semi-detached, or embedded? Pick one, and then apply your magic numbers here. A, B, C, and D basically just plug into these equations, right? So here's our multiplier times lines of code for our particular equation times, or to the power of D. Well, if we are organic, this is 2.5 times kilolines of code to the power of 0.38, right? So I've actually got this later on. Yeah, so basically kind of right here. So again, we're just kind of plugging in numbers. And to you, these numbers probably mean absolutely nothing, right? Like, what the heck does 2.5 mean? What does 0.38 mean? What does this mean? Again, these are empirically designed or developed results, where we know that for this type of project, for this particular set of inputs, for these requirements, for these subjective feelings, this value of C will work, or this value of K will work. Does it mean that it will be perfect? Will you get an absolutely accurate estimate? No, absolutely not. But it will be close, more than likely. So here we have a couple of examples for you here. So we're getting our effort, and again, this is person months. So let's say we're doing an embedded model. We're going to plug in a different value of C, a different value of K than you would for organic or semi-detached, right? Again, these are just from a lookup table. Same thing down here. So basic and intermediate looks exactly the same, except intermediate, you put an M on there. For embedded, you'd also put an M on there. M is going to be derived by what those cost drivers are. And again, it's going to be a lookup table of how you figure out what goes into M, more or less. Very, kind of hand-wavy theoretical for this model. Like, I'm just asking you to take it that it works. But more than likely, it's going to give you a pretty decent view of things. One other thing that we're going to be getting into here as well are a whole bunch of acronyms. So I'm just kind of skipping through this because I want to get to the earned value analysis as well. But the drivers that I'm talking about, those parameters that go into calculating what M is, we're going to figure out how each of them rate on a scale. So from very low to exceptionally high. Again, if you go to that table that I had separately, I don't have it in here, but if it's exceptionally high, this cost driver has this value. That factors in for every cost driver you want to link together, basically. And am I going to ask you to run a Kokomo model? No, I'm not going to ask you to actually do it, but just be aware of how these things are kind of structured. We can even go back to this page, which I actually found kind of interesting. They have a C++ implementation for Kokomo too. So basically, you would put in your drivers, your mode, and then you'd calculate it, and then you get output of it's an organic project, 10.3 person months. We need 6 months of development time, and we need approximately 2 people to run this project. This is the kind of output that you get out of a Kokomo model. And you do it in C, Python, R, Excel, even, whatever your language of choice is. Does the notion of kind of what I'm showing you here make sense more or less? Please go over here. Thank you. Basically, it is a model that you plug data into, and you get effort and timing out of it. Here we start going off the rails in terms of acronyms. I will forget what every single one of them means. For this one, it's not bad, but when we talk about earned value analysis, it goes off the rails a little bit. So we have all of these different cost drivers, and I'll let you kind of read these offline, if you want to get more detail on them, but computation cost, execution time, or main storage, personnel, programmer capability, language experience, application experience, right? These are all can be subjective or very quantitative based on your needs for the project, right? And again, these all factor in. Other side of things, so everything I've shown you so far has actually been for effort. Effort is the number of person months. You can also calculate the development time in months for this. So basically, the number of person months you get out of the last equation, here we plug it into another, very similar equation, and then you get how many actual months the project will take. Right? So again, here's our value of C, here's our value of K. They get plugged in, you get number of months. Sorry, it's called D in this page, but I think it was K in the slides. That 2.5 or yeah, 2.5, 0.38, 0.38. Semi-detached, 2.5, 0.35, 2.5, 0.35. Just plug it in. So for an example here, let's say we're doing the basic model. It's an embedded system, so we care, we have those particular constraints for embedded. We approximate that it's going to be 10,000 lines of code. What does that mean for our model? Well, we're going to plug in our value of C, plug in our value of K here, 3.6 times 10,000 lines of code. So this is kilolines of code. You get 58 person months. So that's how much effort this project will take. We can plug that in to our follow-up equation to figure out how much time it will take. So again, from the model, this 58 goes from here to here. We end up with 9 months of development time. So if we have 50 person months and we have 9 months of effort, does that mean that we can just divide this off and get the approximate number of people we need? Well, yes and no, because for a particular project, your capabilities are going to differ of your employees, right? So if I say 50 divided by 9, that's like 6.4, if I remember the calculation rate. So that means I'm going to need either 6 or 7 people if I were to algorithmically, mathematically look at this. Does that mean that I can just throw 7 people at this problem and it'll be done in 9 months? Not necessarily. Depends on their experience, their familiarity with the problem, depends how well they work together, right? So there's a lot of kind of soft characteristics that go with this. And what I will say too is that it's not a great estimator because you can't just keep throwing more people at a project and expect it to get done sooner. That's kind of one of the mantras I want you to get through your heads. If you become a project manager, don't just throw people at the problem because it will actually make development time longer rather than quicker. You have to bring people up to speed. You have to get them familiar with the project. You have to make sure they work well together, et cetera, et cetera, et cetera. This actually starts expanding the amount of time rather than shortening it. So get the people that you need for the project, give them adequate resources and time, and then you will get a good deliverable. Don't start with a team of 6, realize you're 5 months behind, and then just throw another 10 people at it. That's going to make it take even longer. Which, if you think about it, it makes sense. Let's add more people. It should be a lot quicker, right? Well, it's not that easy, unfortunately. So, nice, big, bold font for you here. It does not depend on the number of engineers. This divider that I mentioned does not give you a useful indication. It does not depend on the number of people. And the reason why I say this again, I kind of want to get to our demos here in a moment, but more people is not always a good thing, basically. Work with the team that you have and see what you can make them, how you can enable them to be successful rather than just throwing more bodies at the problem. All right, so last thing we're going to talk about here before we wrap up is earned value analysis. So this is another way to track efforts and estimate time and all that. This one only really works though if you have the resources. Yes, too many cooks spoil the broth. Absolutely. Everybody's got to throw their own little spice into the mix, right? Absolutely, absolutely good analogy. The other side here too, though, the earned value analysis, this will work if you have everything planned out already. And when I say planned out, I mean you know which resources you have, you know what the tasks you have, how much everything will cost, rate of effort. So basically, we have lots of metrics to work with is kind of the takeaway here. And what we're going to get is basically a soup of acronyms where I'm going to forget every single one of these because I don't use them on a daily basis. But basically, we have budgeted cost of the work, budgeted time at completion, how much work was performed versus how much was actually performed. And these have their little acronyms. And those are going to go into more acronyms. And again, this is where it gets a little complicated, and you basically need to either do this daily or have a lookup table. But let's say that we know like budgeted cost, actual efforts expended, things of that nature. We can take these values, again, whatever they're going to be that you're calculating. And again, I'm being generic, obviously, and I'm not saying this means this means this. I'm trying to get you to step back and look at this at a high level in a way. We can divide things out, we can subtract them off from each other, and depending on which metric you're looking at, you can get these acronyms, right? And again, eyes glossed over probably already. What the heck does schedule performance index mean? What does percent complete actually mean? What is cost variance? Well, if you take this and you go ahead and you calculate all this out, and again, we're just plugging in numbers here. And I will say a lot of these metrics you would get out of like a project management software. So you plug in resources and tasks and efforts and timing. You can actually figure these values out from something like that. But if our SPI value is greater than 1, we're ahead of schedule. If it's less than 1, you're behind schedule. You're under budget, you're over budget. Again, ahead or behind schedule, under or over budget. All these values are telling you, based on these calculations that you do for each of these, is in a very numeric sense where you are project-wise. And can you look at, graphical task management software? We have all these tasks to do. Are you on schedule? It's kind of hard to sometimes see that. But if you run a technique like this, I calculate my schedule performance index. I know that if it's greater than 1, I'm good. If it's under 1, I'm behind, and I have to figure out why and what I have to do to fix that. All right, so here's an example that I'm going to kind of skim through, honestly, because we're not calculating all of these acronyms out. But this is kind of the thing that you would have to do this for. So the project has 56 planned work tasks. We estimate they will take 582 person days to complete. That's how many hours basically a person can work in a day basically here. 12 of the tasks have been completed, 15 should have by this point. So here is our metrics that we would pull out of this paragraph. We would use these values to calculate everything for these acronyms. All right, so we have 15 tasks here. We have the effort that was planned to take care of this task. Then we have the actual effort that it took to take care of it. Right, so we estimated an effort of 12 here. It actually took 12 and a half. And again, this could be person days for this particular technique. So then we start plotting out, or I guess tabulating all of these values. You take that table, you calculate out all of your acronyms, and then we start figuring out, okay, what does everything, calculate to for our initial ones, and then how do they factor in with our comparators, basically. Well, our SPI, after we've calculated everything out, we have a value of 0.81. And we remember from 3 slides ago that if SPI is less than 1, we are behind schedule. Did we know that from here? 12 have been completed, 15 should have been completed? Yeah, kinda. But here, we have a very particular set of values why we're behind. Right, so we are 30 person days behind schedule. Thank you. This is actually the last slide before I talk about that, so but thank you for the reminder. So basically, we are behind schedule. Here's how many days we're behind schedule. Perhaps here is the cost that we're behind. Are we over budget? Are we under budget? Again, basically, you don't necessarily have to know what all these mean right off the top of your head, but you do have to be aware of the purpose of this technique and why you would apply it. Right? Are we behind or ahead of schedule? Are we under or over budget? What metrics plug into this formula? And that's going to be a lot of your estimation techniques, knowing how to apply the model and when to apply it. All right, so thank you for the reminder. Again, I went very fast through this. If you are unsure of anything, please let me know, and I'll be happy to elaborate. But I wanted to touch on your next assignment before, I let you go for the weekend, since you have one due tonight, and I'm going to open the homework up over the weekend. Your next task is going to be to figure out what you have done so far for your term projects, what you have remaining to do, and approximately how much time those tasks have or will take. And I'll probably also ask you to name somebody who is responsible for each task as well. So this is to help you plan out the rest of your semester. Obviously, it's a homework. You're going to get credit for it, but this will help you mentally stay on track. At least to me, having a schedule and a notion of what I have to do helps me a lot. So I'm assuming that will help you all as well. And remember, I care about a minimum viable product. I don't care about a polished, beautiful application. I just want to see something working at the end of the year. The assignments, so I'm going to have you basically create a Gantt chart is what I'd be expecting. You can also do a burn down or burn up chart if you would prefer. Everything I've kind of been talking about so far and having you all consider is more in line with a Gantt chart because we're kind of task-based. But if your teams have been working with things like user stories or, kind of smaller consumable chunks of tasks, a burn down or burn up chart may be appropriate. It just depends on your team. I will accept either of them. And if you are unsure of what any of these terms mean, again, let me know because we covered Gantt and burn up and burn down, I think, a few classes ago. Now, I do not have project. I am not paying for Lucid charts. So what I did is I pulled up a bunch of resources for you all if you want to do this in whichever tool your preference is. So you do Gantt in Google Sheets. You can do burn down, burn up in Excel. You can apply these to any spreadsheeting software, basically. Gantt has a draw.io template, which, let me exit, please. Thank you. Looks kind of like this. These are all just blocks, though, and text boxes, so they don't have any linkage to each other. Like this date is just a text box. I can drag it wherever I want and just completely ruin everything. These numbers are just hand entered, so it's not the greatest, but it is there if you like that. Yes, I'd like to leave. There's a Google Sheets tutorial, again, burn down, burn up. I also have a link to a bunch of open source tools that are out there. I'm going to use Gantt Project in this little demo. There's also a lot of really cool web tools out there. Whether you want to run your own server, whether you want to, use somebody else's application and register for it, that's fine. Gantt project is something I used years ago. It looks kind of like this. It's pretty decent Microsoft project open source variant, basically. So I'll show you this here in a sec. So the thing that I'm going to be asking you to do is to list out what you've done and what you have left to do. Now, what have I done for my term project? Again, I'm trying to follow along with you. Again, A, so that I can learn something fun, and B, so that I can make sure what I'm having you do makes sense. So I've got my my little Python roguelike procedurally generated game. Made some progress. I've got Perlin noise in my tile map. My player and my various entities don't really follow the map right now. I was just kind of playing around with the background. But I've got stuff happening here. All right, so to me, I'm happy with my progress so far. This is also the kind of thing I would expect to see for like your midterm demo. It doesn't have to be working or even super functional, but I just want to see where you're at, right? And more important than it working is understanding what you have left to do and how to take care of that. So what have I done? I wrote a skeleton proposal. I wrote some use cases. Made my Pygame interface. I worked on my tile map. I found a sprite sheet. I hooked that into Pygame. Right, that took me 2 days. This took me 1 day. It took me a week to get Pygame actually running. Perlin noise, I had to figure out which Python module I needed, how to interact with it, how to pull it into my tile map. Entity component took me a lot longer because I didn't understand it. Now I kind of have a grasp on it, but it took me 2 weeks to do. Realistically, it's 5 minutes every other week that I've been able to handle it since I'm focused on class instead of my personal pet projects. And then tracery, so this is going to be my procedurally generated language, my story and all that. It's also going to hook into the world generation. That took me 2 weeks just to understand how that system works. Not all hooked together. So that's what I've done so far. This is the kind of thing I'm expecting you all to do, just to sit and think about what you've done so far. Okay, I am at this point pretty much midterm. What do I have left to do to deliver this project to the mean old professor on the other side of the camera? Well, artifacts-wise, he said he wanted a software requirement specification, so I'm going to have to do that. It's probably going to take 4 weeks, depending, because it's going to have to be well written and all that. Plus, whatever that professor doles out his homework, probably 3 weeks of effort, realistically. So then what do I have to do left implementation-wise? Well, I've got to do some stuff with tracery. That's probably going to take me 2 weeks. My map is Scrolling map has issues. It's going to take me a few days to fix that. I'm going to need some time for the players and the entities to interact. My noise function, I'd like it to be better. Add some meat to the game, 3 weeks about. So here's all the things I want to accomplish, right? So these are my high-level tasks. Can I break this down into subtasks? Absolutely, right? So tracery rules, this is my grammar-based generator. I want it to generate my world. I want it to hook into my NPC conversations. So a week for each of those. If I want to add quest lines, it's going to take me 2 weeks just to figure everything out. So I've got some high-level ideas here. All right, I'm going to move you over here so I can see it. How does that work with a timing and planning software? So if you remember, a Gantt chart follows the waterfall model pretty well. So I'm going to basically get an enumerated or kind of a nice hierarchical view of all my tasks, plus who's responsible. So in here, I'm going to assign a resource, so that's going to be me, Eric Fredericks. I can put what the days off this person has. I can offer how much I would pay you, any custom data, but basically you can start planning out what engineers will be working when in here, right? So I'm a person, I'm just going to work full time. All right, I've got some tasks I need to do. So I need to do my software, let's just call it SRS. So that's my requirement spec. Double click it. It's going to start, let's say, at the 26th. It's going to take me 4 weeks, I said, so that's 28 days. All right, resource, I'm going to add Eric to it. All right, so here's my timeline for my SRS. All right, it's going to start week 44. It's going to end week 40, which, hey, oddly enough, is pretty close to final exam time, right? So we have that. I also need to do my fix scrolling map problems. All right, so I've got this task. I'm gonna start it, let's say tomorrow. That's gonna take me 3 days. So 3 days. Again, I'm responsible. Oops, predecessors, don't want that one. I'm responsible. Great. I want this to start, let's see, not December 3rd. I want it to start tomorrow. Thank you. Oh, it's not going to let me because this is interesting. I forgot it didn't do this to me last class because I forgot to add responsible parties. I have 100% effort assigned to the SRS. And it's assuming that once I'm done with the SRS, I will go to work on this part. So that's interesting. I'll have to play with that. Basically, we have a dependency of resources here. All right, so let me maybe take off the responsible party here. Let's say 50. I think you can play with timing, so 50%. And I think in here, if I do, I'm just trying to see if I can get this to play nicely with what I want it to do. 50%. All right, can I drag you now? Nope, it's not letting me drag you. 26th? Nope, all right. I thought I could move that. Anyway, let me add another task. So add towns. This is going to take a week. So let's start it today. It's going to take 7 days. Perfect. So I see that this guy's over here. I could say that I want this to be done before my SRS is done. So add towns, then I'm going to work on my SRS, and then I'm going to fix my scrolling map problems. So the whole point is you can kind of see how tasks start to stack up over time, right? I can move this up. I can move this up so that we get a nice little hierarchical view. Let's say that I am assigned all of these. I know it's possible to overlap them. In here, when I'm clicking around in class, apparently I'm not seeing it. So I see stacked timings, right? I see tasks that can be overlaid. What else can I get out of this? Well, I see the people involved, so here is my effort over time. I also can look at a PERT chart, if we remember the critical path method from several classes ago. Well, here is a simple PERT chart. I'm going to start on my add towns task here. It's going to take me 7 days. Then I'm going to do my SRS, and then I'm going to fix my scrolling map problems. We see duration. We see the overall path of these activities, right? So this is kind of nifty that we can get different views like this. All right, let's say that you have to turn this in, because it's an assignment. Well, you can export it to PDF. And I can say export. It's going to go, I think it goes into a weird place. Doesn't quite go into my documents by default. Users. And then I believe it is this guy. Yep. So here's my Gantt chart, PDF export. So I've got some high-level info. I've got my tasks. I've got their dates. I have the person who is assigned to these, and then I see my actual task list and my effort estimation. So all of these kind of metrics that I was talking about in the lecture, right, with like earned value or your Kokomo models or any of your estimations, you can probably fill a lot of those values in with some kind of a task managing software like this. And again, this is for the Gantt model. If you wanted to do burn down or burn up charts, since I've got a second here in class left over, I guess if anybody has any questions on this, please drop it in the chat before class is over. But there's also kind of this burn down or burn up chart in Excel. So if you can track basically how many user stories you have, or basically how much effort you have done versus how much you expect to impart, you create an Excel spreadsheet, and then you basically do a line graph, and then you get something that kind of looks like a burn down or a burn up chart later on here. So that's it for class today. I hope you all have a wonderful weekend. Again, homework's due tonight if you joined late. Next homework will go up very soon. It'll probably go hand in hand with the midterm requirements, so you can all start planning for that. Other than that, I hope you all have a wonderful weekend. These slides in In Blackboard, we're updated with all these links as well. So if you want any of these, they're in the PDF now. I put that up last night, basically. So other than that, have a wonderful weekend. I will see you on Monday, and we will continue on with more UML. So bye, everybody. Have a good time. It's a really weird outro. Have a good weekend. There we go. Nailed it. All right, bye, everybody. Did you post the midterm requirements? Not yet. I've got it there in verbal and in text. See you Monday. Ciao.